Now we will start with the matching. Now, matching in a graph. We are discussing the matching in a graph. Matching in a graph means it is a subgraph where we take those edges who are not incident with each other. Now, suppose we will take here a graph. Now the graph is V1, V2, V3, V4. Corresponding edges E1, E2, E3, E4, and this is E5. First, matching means it is a subgraph of your graph G where we take those edges who are not incident with each other. That means if we take the V1, V2 vertex, V1, V2, these two vertex, then we have to take V3, V4, and we will consider it as a matching M1. Now, if we draw this, as this is a subgraph, so we will take this is V1, V2, and this is V3, V4, right? Similarly, we can take another two, V1, V4, V2, V3, right? This is, we will mark it by M2. Now M3, V1, V2, V3, V4. We will take here the E5. This is E1, E3. This is E2, E4. This is E5. Now, also we know that if we will take all these vertices and no edges we can take there, this is also a matching M4. Clear? These all are these matchings. Now we have to find out the maximal matching. Maximal matching means if in any matching, if we can add any one edge, then the matching conditions are not satisfied. Now, if we connect this edge, then matching property is violated here as these two are the adjacent edges. So we can't draw this. So M1 is a maximal matching. Again, M2, if we connect this edge, again it will violate your matching property. So M2 is also a maximal matching. Now go for the M3. If we add any one of the edge, then this is also violated the matching property. So this is also maximal matching. Now go for the M4. We can add this edge. This is not violated your matching property. We can also add this edge. This is also not violating your matching in a graph property. That means M4 is not a maximal matching. This is a matching, but this is not a maximal matching. Now, maximum matching. Out of this maximal matching, here we will consider two edges. Here we will consider two edges. Here how many edges are containing? One edges. That means in a maximal matching, if the number of edges is maximum, then it is called the maximal matching. So these two are the maximum matching, as that the number of edges is highest. That's why this is called the maximum matching. Now perfect matching. When it is called a perfect matching, look at that. Every vertex V1, V2, V3, V4. All vertex degree is 1. And this is the all vertex degree is 1. That means there is a one-to-one connection between this vertices. Here is also every vertex degree is 1. If in any maximal matching, each vertex degree is 1, then we call it a perfect matching. So this M1, M2 is a perfect matching. That means maximal or maximum matching is always a perfect matching. Perfect matching is always a maximal or maximum matching, but converse is not true. This is all about the matching in a graph, right? For your sake, you will take any one of this graph. The graph is A, B, C. This is your D, E, F. Now, first we have to find out the maximal matching, right? So, for that we've considered we can take AB. If we will take the AB, BC cannot be taken, but we can take CD and EF, right? This one is a matching one. You can draw this matching one, AB, CD and EF. AB, CD, EF. Right? Now, another can be BC, EF. This can be another matching M2. But this is not a, this is another matching, and this is also a maximal matching. M1 is a maximal matching, M2 is also a maximal matching. If you connect any one of the edges, then it will violate the matching property. That's why this is also a maximal matching. Now, again, you can take AB, EC, AB, EC. This is also a maximal matching. In this way, you can find out the maximal matching. Now, out of this, there is how many edges are containing? 2 edges. There is also 2 edges. So, both are not the maximum matching. Who is one the maximum matching? M1 is the maximum matching. And this is also the perfect matching. Clear? So, matching in a graph is all about this.